Hi everyone, Miss Barron here. So today I'm going to go over how to balance chemical equations. Now there are a lot of different ways that this can be taught. It's up to you what method you prefer. I have a certain method that I like, and that's what I'm going to teach because I just think it's the quickest and easiest way. In your OneNote though, once you have more stuff in there are some helpful videos that teach you other different methods for balancing chemical equations, but I'm going to show you guys how I do it. So first thing, why do we balance chemical equations? So something like this, okay? Why do we balance them? Well, according to the law of conservation, matter cannot be created or destroyed. That's why we need to balance a chemical equation, so we have the same number of atoms, which is matter, on either side of the equation before and after the reaction. Remember that reactants, those are on the left-hand side of the equation, or left to the arrow, and your products are to the right of the arrow. And you need to make sure that your reactants and your products on either side have the same amount of each element or atom on either side. However, you cannot change the subscript, so you cannot change these little numbers in order to balance a chemical equation. Rather, you have to change the number in the front, which we call the coefficient. That's what I have highlighted in yellow. And we change those numbers in order to balance the chemical equation. Sometimes you can write 1, so writing 1 as a coefficient is not necessary. You could just leave this as a just blank empty space, but if you'd like to write a 1 there, you're more than welcome to. Again, make sure you have the same number of each element or atom on either side. Sometimes balancing requires trial and error, and that's okay. You are going to see those polyatomic ions again, so those things on the back of your periodic table that are in parentheses, okay? We're going to, again, still treat those as individual entities, okay? So for instance, photosynthesis, you guys saw this in biology. So this is a balanced chemical equation. If you look on either side, we have the same amount of each element. So there are 6 carbon on either side. So I have 1 carbon here, but I have a 6 in the front. So again, the number in the front, that coefficient gets distributed essentially to each element. I'm saying I have 6 CO2s. So that means I have 1 carbon here, and I have the 6 in the front. So that means I have 6 carbons there. However, on this side, that 6 already is there as the subscript, so I have to put a 1 in the front to get that to be 6. Hydrogen, I'll get to oxygen last. Hydrogen here, you have 6 in the front and there's that 2 subscript. 6 times 2 is 12. So that's how I'm getting 12 hydrogens. There's already a 12 here. And then oxygen is where it gets tricky because notice oxygen is in multiple places. So here, 6 times 2 is going to be 12. So there's 12 oxygens there. 6 times 1, there's just 1 O there, and there's a 6 in the front, is 6. So 12 plus 6 gives you 18. Over here on this side, notice there's 6 oxygen here, and there's a 1 in the front. So that's 6 oxygen plus, this is 6 O2. So 6 times 2 is 12, and that gives you 18. So oxygen can be a little tricky if it's in multiple places. All right, so I do have some videos here if you'd like to watch those just to get an understanding, okay? And then of course the link to my screencast video is going to be right there, and that's going to help you get through these problems. All right, so let's start with an easy one. So some of you may have learned the method where underneath you kind of keep a tally of everything, and there's the bell. Which is fine. Personally, I don't like that method. I just think it takes too much time. I kind of just like to go back and forth until everything is balanced. So it's up to you what method you would like to use. Again, in your OneNote, I'll have links to many different videos. So here's what I like to do. So for this first example, we only have 2 elements, which is super easy. So let's start with Hg, which is mercury. So again, here's our arrow. We have to make sure we have the same amount of elements on either side of the arrow. So I have 1 Hg here and 1 Hg there. So that's good. Now I'm going to look at oxygen. So I have 1 oxygen here and I have 2 oxygen here. Well, that's not equal. So how can I get them to be the same? Well, again, I can only put a number in the front. That's what these spaces are for. So what I can do is I could put a 2 here. If I put a 2 here, remember that gets distributed to everything. We're saying, essentially this is saying you have 2 of these, okay? So if I put that in the front, oxygen is good. Now I have 2 oxygens here and 2 oxygens here. But when you put that 2 in the front, now you have 2 mercuries. So now if I go to the other side of the equation, I can put a 2 here. So now I have 2 oxygens on either side, 2 and 2. And I have 2 mercuries on either side of that equation. Again, on either side of this arrow. Now you can leave this blank if you'd like, that's acceptable, or you can put a 1 there. I accept either one. So now this is completely balanced. You have to make sure you have the same amount on either side of that equation. All right, now let's get to a more difficult problem. One thing I will say is when it comes to oxygens and hydrogens, I recommend doing those last. And then in this one, and I'll address that here when we get there in a moment. Also, I'm going to address the polyatomic ions as well. All right, so let's start here. I'm going to start with Fe. So here's Fe. Again, either side of that equation. So there's 1 Fe over here on the left side. There's 1 Fe over here on the right side. Okay, that's all fine and dandy. Now let's move on to Cl. So there are 3 Cl's here and 2 here. So you kind of have to think here, what is kind of the least common multiple then between them, okay? It's not like up here where I had a 2 and a 1, and I could easily put a 2 in the front to make them both 2. We have a 2 and a 3. So the easiest thing to do in this situation is I'm going to put a 3 here and a 2 here, because 2 times 3 is 6. So now I have 6 chlorines, Cl's, on this side. Again, that 2 gets distributed to everything. This is like saying I have 2 of these. That's what that is saying. So I have 6 chlorines on this side, and I have 6 chlorines on this side, because 3 times 2. Okay. However, when I did that, okay, I changed some things, okay? I'm going to start over here. So when I put this 3 in the front, now I'm saying that I have 3 Mg, okay? Which actually you're going to find works out sometimes, because guess what? There's 3 Mg or magnesium over here. So that means so far our chlorine and our magnesium are balanced. Let's go back over here. So now you put that 2 in the front. Well, now you're saying you have 2 Fe, which is iron. And I have 1 Fe over here. So to get them to be the same, I'm going to put a 2 in the front here. Now this actually works out. When it comes to your polyatomic ions, which I'm going to highlight, treat those, so here's one and here's one. Treat those as if they were individual elements. So over here, you're saying I have 2 PO4s, okay? Because again, if I was to write this out, it'd be saying I have 2 of these. So I have 2 PO4s. Okay, treat the PO4, which is polyatomic ion, as if it were one individual thing. I personally think it's a lot more difficult to count up the P's and the O's separately. So I just keep them together. And notice on this side of the equation, that subscript on the outside is saying you have 2 PO4s. So I have 2 PO4s here, 2 PO4s here. This equation is balanced. Again, you can leave this blank, or you can put a 1 there. Again, I like to treat the polyatomic ions. I like to keep them together. There are some videos that I have links to where some people like to keep them together and some people like to keep them separate. I think it's easier just to keep them together. There might be some situations where you won't see the same polyatomic ion on either side, which can happen, and I'm going to address that in the next problem. All right. So now we're on our third example. So we have I'm going to start with calcium. So we have 1 calcium on either side. That's great. With something like this, I'm going to do the hydrogens and oxygens last, because notice the OH, which is a polyatomic ion, I don't see that over here. It's been broken up. So I'm actually going to do that last. The O's and the H. So let's move on to SO4. So notice I have 1 SO4 here and 1 SO4 here. So that's good. All right, now I'm going to start looking at those oxygens. Again, these are individuals, so I'm not going to pay attention to the oxygen that's in that SO4, okay? Because I'm treating it as an individual entity. So we're going to ignore those oxygens in there. So let's look on this. Let's look over here. So again, that 2's on the outside. So this is saying we have 2 OHs. So that's saying that I have 2 oxygens, okay? Over here, I only have 1 oxygen, okay? So to get them to be the same, I'm going to put a 2 in the front. Now when I did that, now I have 4 hydrogens. Again, that 2 gets distributed to everything. So for this hydrogen, 2 times 2 is 4. So I have 4 hydrogens on this side, which actually works out, because if you look on this side over here, there's 2 hydrogens there, and there's 2 hydrogens there. Well, 2 plus 2 is 4. So I have 4 hydrogens on either side. Okay, again, 2 from here, 2 from here. 2 plus 2 is 4. There's 2 hydrogens here. 2 times 2 is 4. My oxygens, I have 2 oxygens here, 2 oxygens here, 1 calcium, and then as I boxed it, I have 1 SO4, 1 SO4. So this is actually balanced. Again, you could leave these blank, or you can write the 1's in there, okay? Sometimes you'll have equations that require, you have to write 1 number to balance it. Some it might require more. It just depends on the equation. So that's how I like to balance. I just kind of go back and forth and checking to make sure that I have the same amount on each side. If you like the method where underneath you kind of keep a tally of everything, that is fine as well. There's many different videos out there that have different techniques. This is the technique I like to use. I'm just going to finish by highlighting that other polyatomic ion. Again, I like to treat those as individuals. So I've gone through some examples. There are plenty of videos available to you. So I want you to try balancing these 3 on your own. I'm going to point out the polyatomic ions that you want to keep together, which is only in that one problem. Okay? Sometimes they get split up, but if you see the same polyatomic ion on either side, make sure you keep them together.